I am Mrs. S.MALATHY, Head Associate Professor of Chemistry. I am going to talk about biocatalysts for second MSc Chemistry students. What is a catalyst? A catalyst is a substance which alters the rate of a reaction. This phenomenon is known as catalysis. The use of catalyst is it facilitates transformation without the catalyst being consumed in the reaction and without being incorporated in the final product. That is the use of the catalyst. Then the development and advancement of catalysis is important for both economic and environmental sustainability of the world. So the area of catalysis can rightly be referred to as the cornerstone of green chemistry. For example, the waste generated in the manufacture of fine chemicals and pharmaceuticals is largely due to the use of stoichiometric inorganic and organic reagents that are partially incorporated or not incorporated into the product. For example, the oxidation using inorganic oxidants like chromium 6 salts and permanganates and manganese dioxide. Then reductions using sodium, magnesium, zinc and iron, and also the reduction using metal hydrides. Example, lithium aluminum hydride, sodium borohydride, and the mineral acids like sulfuric acid, hydrogen fluoride and phosphoric acid, and also Lewis acids like aluminum chloride, zinc chloride and BF3 are major sources of waste. Then the ultimate step and atom economy is the development of catalytic cascade process, where several catalytic steps are integrated in one part procedures without the need for isolation of intermediates. And also another advantage is less waste that afford substantial and economic and environmental benefits. Furthermore, coupling of reactions can be used to derive equilibria toward product, thus avoiding the need for excess reagents. Then what is biocatalysis? Biocatalysis is the use of catalyst derived from nature to catalyze chemical reactions. It has many attractive features in the context of green chemistry and also in sustainable development. A catalyst is, for example, biocatalyst, example, enzyme is derived from renewable resources, and also it is in biocompatible and sometimes it can be edible, and also it is biodegradable and essentially non-hazardous. That is, it fulfills the criteria of sustainability remarkably well. That type of substances are that phenomenon is known as biocatalysis. Then biocatalysis avoid the use of, the contamination of, the scarce of precious metals like palladium, platinum and rhodium. The reactions are performed in an environmentally compatible solvent like water and also under mild conditions like physiological pH and ambient temperature and pressure. Example, the catalytic hydrogenation, oxidation and carbonylation are highly atom efficient process. The use of recyclable solid, heterogeneous solid and also acids and bases are used as catalysts, which result in substantial reduction in waste in industrial organic synthesis. So the several pharma companies have developed reagent guides for particular reaction with the aim of improving the greenness and sustainability of their process. Such telescoping of multiple step synthesis into catalytic cascades has several advantages. Example, fewer unit operation is enough and less solvent and reactor volume is also less and shorter cycle times, and also another advantage is higher volumetric and space time yields. So it is very much useful Then the reactions of multifunctional molecules proceed with high activities, and it is chemoselective, regioselective, and also stereoselectivities, and generally without the need for functional group activation or protection or deprotection. That steps are not required in the traditional organic synthesis. The biocatalytic processes are more step economic, and also it is more efficient in energy, and the raw material consumption is also economic, and it generates less waste, and also are environmentally and economically more attractive than conventional synthesis. As a direct result of higher selectivities and milder reaction conditions, biocatalytic processes often afford products in higher purity than traditional chemical process or chemocatalytic process. Example, the biocatalytic process are also known as enzymatic process, can be conducted in standard multi-purpose batch reactors, and hence do not require any extra investment. For example, you do not require any high pressure equipment. Then the biocatalytic reactions are conducted under roughly the same conditions of temperature and pressure, and hence it is relatively easy to integrate multiple reactions into eco-efficient catalytic cascade processes. Now we will see one of the biocatalyst. A biocatalyst, especially an enzyme that initiates or modifies the rate of chemical reaction in a living body, is termed as biocatalyst. They are enzymes or microbes that initiate or accelerate chemical reactions. What are the advantages of biocatalytic conversions? Most of the reactions are performed in aqueous medium at ambient temperature and pressure. Another advantage is the biocatalytic conversions are normally involve only one step. The reactions are fast reactions. The conversions are chemoselective, regioselective, and also it is stereoselective. Now we will discuss about the type of biocatalysts. Example, the microbes, lipase, protease, cellulase, and amylases. The microbes, example, yeast and other anaerobic bacteria. The lipases, they are the most widely used class of enzymes in organic synthesis. They are preferred widely because of their better stability as compared to others. Proteases, it is an enzyme which break down proteins. Cellulase, enzyme which break down cellulose. Amylases, which break down starch into simple sugars. Then why we use enzyme? Enzymes speed up chemical reactions in a natural ways. As they are not alive, they remain as inert mass of proteins. The enzymes work by weakening bonds, which lowers activation energy. The mechanism of enzyme action, here the substrate is entering into the active site of the enzyme. The active site is nothing but the special region in the enzyme, and when the substrate enters into the enzyme, there will be a change taking place in the bonds. The enzyme changes shape slightly as substrate binds, so that it forms enzyme substrate complex, and it gives the product known as enzyme complex or product complex. Then the products are leaving, and the active sites of enzymes are left behind. These are the different steps involved. First step is the binding the substrate to the active site of the enzyme. The active site is nothing but the specific region of the enzyme which combines with the substrate. Second step is changes in the distribution of electrons in the chemical bonds of the substrate. Then the reactions that lead to the formation of product is the third step. Then the fourth step, the products are released and the enzyme is ready to catalyze another reaction. Then what are the uses of biocatalyst in green chemistry? The use of biotechnology gives enormous new innovative opportunities for green chemistry processes in industry. This is because the use of biocatalysts for industrial production is inherently green, as most biocatalysts are clean and non-toxic as opposed to non-biocatalysts that are mostly toxic metals. In short, the biocatalyst fits very well with the principles of green chemistry. There are 12 principles in green chemistry. Here the biocatalyst fits very well with the principles of green chemistry and sustainability. The first principle is waste prevention. That is, the biocatalyst enables more sustainable routes which significantly reduce waste. Second principle is atom economy. That is, 100% of the reactant should be converted into 100% of the product. Here the biocatalyst enables more atom and step economic routes. And the third one is less hazardous synthesis. Usually the biocatalysts do not produce any toxicity. Then the fourth one is design for safer products. This is not relevant according to the biocatalyst because already we have to design the product. So next one is the fifth principle is safer solvents and auxiliaries. Usually the biocatalytic reactions are performed in water or green solvents, so safer solvents and auxiliaries can be used. And also next one is energy efficient. It should be the energy efficient, the process should be energy efficient. Here only mild conditions are used with energy efficiency. Next, the renewable feedstock should be used. Here enzymes are renewable and it reduces derivatization. The biocatalysts obviate the need for protection and deprotection. And also the catalysis should be followed. Here enzymes are itself is a catalyst. Then design for degradation, not really relevant, but the enzymes themselves are biodegradable. Then real-time analysis for pollution prevention, it can be applicable in biocatalytic process. And next, last principle is the inherently safer process. The biocatalytic process are performed under mild and safe conditions, acceptable prices and to manipulate. This is applicable to biocatalytic reactions also. Then in developing countries could contribute enormously to achieve green chemistry principles by using their unique, diverse and abundant natural resources to perform biotransformation. This is however possible if effective and sustainable use of biological feedstocks and generation of novel biocatalysts is achieved. The biocatalysts are capable of providing high selectivities. For example, both stereoselectivity and regioselectivity without using protection, deprotection groups, and in this way biocatalysts produce isomers as compared to racemic mixture for non-biocatalysts. The latter efficiency alone save energy, time, material, cost and also other separation procedures. By producing pure desired isomers, it implies that the traditional downstream steps needed to achieve the desired purity are avoided. Generally, the traditional downstream process involve multi-step process and incur an overall increase in time, cost, energy, material and waste disposal cost, which can be greatly reduced by the use of biocatalysis. The application of biocatalysis in chemical reactions, however, hampered by the natural harsh chemical reaction of most chemical reactions of biocatalyst require narrow operational parameters. This implies that there are limited operational conditions for the biocatalyst reaction. as the biocatalyst may be denatured, causing a loss of its catalytic activity. This can be overcome by carrying out reactions at enzyme optimal reaction conditions or by modification and or imprinting of this biocatalyst along with the manipulation of chemical reaction environment. Another drawback of use of biocatalysts are it is prone to product or substrate inhibition, causing the biocatalysts to work at a higher substrate and product concentration. That can be avoided by using low substrate concentration through a continuous addition. Whereas the product inhibition can theoretically be circumvented by physical product removal from the reaction system. Despite some practical problems, the use of enzyme as practical industrial catalysts for chemical manufacturing sector is already a valuable tool for production of both commodity and fine chemicals. So, biocatalytic process is very much useful in the production of fine chemicals. Then at present, biocatalysts are important in the manufacture of intermediate, fine and commodity chemicals, especially where enantio and regio selectivity are the key requirements. The transformations involve use of whole cell enzyme or partially purified enzyme catalyst. Although the industrial biotransformation is mainly on fine chemicals, the industrial production of commodity or bulk chemicals is also beginning to be common. Example, the Mississippi rayon is for instance using nitrile hydratase biocatalyst from Rhodococcus rhodocoronus to produce acrylamide on a scale of more than 30,000 tons per year. Here one of the example is the acrylonitrile. In the presence of nitrile hydratase, it is converted into acrylamide, which is used for the synthesis of acrylamide. Another example of biocatalyzed commodity production is the production of fructose from glucose using glucose isomerase enzyme. About 1 lakh tons of fructose per annum are produced by different companies through this production route. The outstanding high selectivity of biocatalysts make it vital in the production of fine chemicals. This is because enantiomerically pure compounds are selectively achieved. In fine chemical production, the biocatalytic resolution is used. That is, the use of enzyme selectivity for one enantiomer of chiral molecule to selectivity converted to the desired enantiomerically pure product, while the other enantiomer of racemate is virtually intact. Example, the most prominent group of enzyme in the production of fine chemicals by biocatalytic resolution are hydrolases. For example, lipases, amidases, aminopeptidases. See the example, the alpha phenyl ethyl acetamide on reaction with the acetic ester, in the presence of lipase, it is converted into S isomer of alpha phenyl ethyl acetamide and also R phenyl ethyl acetamide. The another example is industrially using pseudomonas lipase to get access to a broad range of enantiomerically pure S and R amines on a scale of about 100 tons per annum. Here we can prepare S phenyl ethyl amine. From RS alpha PEA to ethoxy ethyl acetate in the presence of lipase, you can prepare S alpha PEA plus R phenyl ethyl acetamide. So it is selectively prepare S isomer. Then application, the biocatalysts are used in food industry for processing. It is used in diagnostic test, and the biocatalysts are the most important aspect in molecular biology. For example, in DNA replication and cloning, and Arbutin is the most common skin lightener and is known to inhibit melanogenesis without causing melanocytotoxicity. What is DNA replication? Is a biological process that occurs in all living organisms. The biocatalysts are the most important aspect in molecular biology. The polymerase, which is used to polymerase, restrictase, which is used to cut the DNA strands, the DNA ligases, which is used to bind the DNA strands. See the DNA replication. This is the original DNA. Then the DNA polymerase make it polymerized. Replication is done by the method, biocatalytic method.